So my name is Codrin, as you please, and I'm trained and I worked in architecture and as a materials engineer and in visual arts, and I now practice as a design researcher. And I work at the intersection of physical, digital, and virtual space. So I'll go through two prototypes today as I discuss how do we apply 3D scanning and 360 technologies to complex environments. And this is the first example, which we'll see. It's 3D scan of the DX Edit exhibit. And on the top floor, you'll see an LASG project. And we'll just go through it. So what really interests me about 360 scanning, 3D scanning, is you're able to actually see from a variety of perspectives. And you can actually rotate the model and actually capture the as-built conditions of the space. And then you can actually zoom in at different levels of detail. And then this also gives users the opportunity to actually focus in on their particular topic of interest, whether you're designing an exhibit or actually an architect who's trying to understand the as-built conditions, and there you see the actual exhibit. So I'm interested in how the components connect with the larger whole of physical space. And today we'll discuss, well, how is 3D scanning and 360 media, how are they different from conventional methods to document and capture spaces? And how do we actually capture the interactions with building occupants? And I will run through a number of demos to actually try to engage in a conversation and try to perhaps pose, well, what might we be able to do with this? And a good starting point is the field of view. So we all experience this. The field of view is the extent of the observable world that is seen at any given moment. And for a camera, the field of view usually refers to the widest capture potential of the lens or a series of lenses, as we'll see with 360 technologies. And going back to the history, starting from the camera obscura, you notice how by creating a pinhole in a dark room, you actually were able to see an inverted image, and that forms the basis for what would end up being a portable camera obscura or a portable camera. And then throughout history, you see how the history of capturing the still image has moved to the moving image and the advent of film. And what you see here is the earliest images that were captured with these new technologies at the time, from an 8-hour exposure of one of the first photographic images to a stereoscopic image, which is an image projected on the left eye and on the right eye through a stereoscope, which is very familiar, as you see in today's VR cameras. And then we try to capture the decisive moment with still images, and then the advent of film, we start noticing that what all of these still have in common is they're still bounded by a frame. Well, with these new technologies, what happens if we actually can remove the frame and expand the field of view so we can actually see the entire 360? Not all at once, but we give people the opportunity to look at aspects of the image or the scene that interest them. And in my paper, I go into greater detail, but just sort of will explore this in four main points. So with these new technologies, it involves learning to switch perspectives between a human and a machine point of view. And what I'll do is I'll give a visual demo of how do we actually see from a machine's perspective, and then how do we actually make sense through these sensors and lenses. And the idea is that 3D and 360 are still fairly new, but they can be used as a way to enable better human understanding towards design research or other applications towards archiving and documenting spaces. And then, well, with 360 video, we might be able to actually capture more dynamic interactions with building occupants for ephemeral events, such as openings. And what I'll now do is I'll sort of go from the familiar image that we see to how a machine sort of interprets the space and go through the process of, well, this is the ROM exhibit you might have been familiar with throughout the discussion this weekend. And the starting point for capturing and documenting these spaces in 3D involves, well, you start to think from how does a machine want to interpret the space? It's not necessarily the same as the human point of view, because what the machine can't see through its line of sight, it can't capture. And don't get me wrong, the eye level is still important for when we're trying to actually reconstruct like a 360 tour and to actually be able to give people the perspective of a spectator there. But what's necessary sometimes is you actually have to invent methods and improvise with terms, how do you actually capture the entirety of the space? And this is a challenge and a great opportunity. So what you're seeing here is those individual scans taken at different heights are now combined, and these are called hotspots. And ultimately, you're able to link them together, and you're also able to hide them as necessary. And then this gives privileged views. If you're a designer or with looking at the process, you're interested in documenting the space, you can actually look at the top view. But then if you want to just make the exhibit accessible in virtual reality, you can just give them a chance to make different models for different types of users. And what emerges is you go from having a 2D plan to actually being able to see the space in 3D. And you now have 6 degrees of freedom to be able to actually move anywhere throughout the space, albeit at a lower resolution as interpreted through the machine's eyes. And so, as you can tell, the fidelity of the image sort of depends on the resolution of the scanner. And it's early days, but I think some promising starting points. So this is just giving you some of the functionality of, well, different users can actually apply this, and from their own point of view, whether you're an engineer or an architect or a designer, you can actually approach it from your own perspective and take the details that are important to you. And what lies underneath all of this data is essentially data. And so when a scanner sort of rotates and captures its surroundings, what you're seeing is it takes about 4 million data points. And then you're actually seeing the as-built conditions, and all those millions of points are then aligned and registered into a common coordinate system in the XYZ plane. And you're seeing like a low fidelity point cloud version of what reality is. And the solidity we once were so familiar in the real world no longer really applies, because these are just data points. And essentially, all that is solid melts into data. And so with these new capabilities, it gives you a chance to actually archive spaces or archive moments in time. So if I was the ROM, you could document different iterations of this, the different exhibits that happen here, and how the spaces are used. And from the point cloud, you create these mesh models. And again, the resolution depends on the capacity of the scanner. But you see layers of data from the point cloud, the mesh, and then the textures on top of it. And you're actually able to see that the surfaces that were so solid become quite evocative and beautiful. And you can map it in different ways. So, well, how do you make sense of this? What I like about these views is that they're so foreign, they're so unexpected, that we're able to see things that are like beyond what we normally see with our visual eyes, and we can see the depth of things, and the layers sort of all layered together. And it brings new attention to, say, the columns or the roof slats. You start to see from the machine's perspective. So my interest is more in showing these technologies and their capabilities in order to find new prototypes and new uses. And so this is the part that I welcome conversation and to see where these things could go. And what we've seen so far is we capture still images of physical spaces, but how do we actually capture the interactions with people in a more dynamic way? And what 360 video allows is you can capture the entire field of view. So this uses two cameras, one 180-degree camera facing forward and one facing backwards. But the more sophisticated cameras can combine a number from 6 to 12 images and can even capture the space in stereoscopic 3D. And the initial captures are all converted to this equirectangular format, which is an industry standard from which you can actually input into any player. And what you're able to do is you're able to start seeing how people actually interact more naturally with the environment. And you can see noises, and this just switches between the two different views to give you a bit of perspective. And you can imagine that by finding an ethical way to position these in public spaces with permission of users or the public, you can actually find a way to actually see how people use the space in expected and unexpected ways. And a quicker way, if 3D scanning is a bit tedious or it takes too long, you can also gain a way to share the space by walking around and actually documenting the space. And you can pause it, and you can view this in a VR headset, or you can pause it on a screen at any moment. And then different user groups can actually look at the parts of the project that might actually interest them, and actually you gain a multiplicity of views coming from it. And this is especially when you have very dynamic conditions and you see some unexpected interactions. It's a way that beyond just the 2D medium, by having a 360 view, you can actually capture everything at once and then process it later by human or other technologies. And the last part of this is you can actually, when you play it back in a headset, the new generation of headsets essentially sort of captures the eye movements of different viewers, and this is an aggregate heat map of how different people, the different aspects they chose to look at. So you have a way to actually measure, and there's increasing interest in this with respects to how do you not only capture space, the data of the real site conditions, but how do you actually view it back in a virtual headset. And finally, so, well, where are these technologies and where are they going and how will they be used in the future? And so going back to the 1990s, I just wanted to do a little quote, and the changes triggered by innovation on visual representation was studied by sociologist Catherine Henderson, as computer-aided design was widely adopted in the design process. And she analyzed sketches, drawings, and these emerging computer graphic systems that designers use as thinking tools, which Sarah mentioned in the first day. And it revealed that changes in the structure of the interactions with old and new artifacts. And as one manager is quoted as saying, "I can't think without my drafting table." So it's easy to go back 20 years and actually try to remember how we used to think about the future, or what tools we used to think back then. And going forward 20 years, it'll be a little more interesting. And I'm just curious to see where it goes. And thank you.